But what we found out is under normal acceleration, that vehicle, typical driving, like accelerating up an on-ramp, let's say going up on the freeway, getting up to 70 miles an hour, the air moving through the filter was only 4 miles an hour maximum. Once we got the vehicle up to speed, we were dealing now with only 1 mile per hour. That is the air moving through the filter. That's the airspeed that would have to move the oil off the filter. 4 miles an hour, that's walking speed down the hallway. So we took it to an even further extreme, and we held it in second gear, and we ran the same vehicle all the way to red line, holding it in second gear, and we reached a maximum of 12. But if you run the math on it, what you find out is that 10 to 12 miles an hour going through that filter, which is 100 square inches, does translate out to about 90 miles an hour at the throttle body. But you've got to back up. The oil has to come off of the filter, and that's where the 100 square inches are. That has about 1 ounce of K&N oil on it. We used an additional piece of equipment here at K&N in our laboratory, which is an air filtration stand in which an absolute filter is used. If anything gets through the test filter, it gets trapped by the absolute filter. So you weigh it, you have an exact weight in the beginning. So if anything moves through our filter that's put in place, it gets trapped by the absolute, and it's going to show up in the weight. So what we did is we took one of our filters and we intentionally over-oiled it by approximately 30%. We put it in that test stand and we ran it at 1,000 CFM for 3 days straight. And at the end of the 3 days, there was no detectable weight gain at all by the absolute. And we weighed the filter also to see if any weight had left the filter and maybe was trapped in the air ducting or something. And it had lost no weight at all. So no oil came off of that filter after 3 days of being subjected to 1,000 CFM.
To provide you with an overall summary of the results of our testing, I'm going to share with you some specific information and refer you to some charts. As of February 2007, we've physically recovered and subjected to testing 107 individual mass airflow sensors of different types and varieties depending upon the circumstances or the vehicles that they came out of. Now, out of the 107 sensors that we physically looked at in this way over the last 2.5 years, I guess it's been, there were 65 of the sensors that were actually functioning perfectly fine. So in other words, 65, over 50% of the 107 sensors that we recovered were never malfunctioning in the first place. Out of the 42 sensors that we found to be malfunctioning, 19 of them were the result of a complete electronic failure, which means that when we would apply an electrical voltage to one end of the sensor, regardless of the condition of the sensor, it should still be able to pass some level of current to the other end of the sensor if the material is simply conducting electricity. And in 19 of these cases, there was no conduction happening at all, so it was in essence a material failure in that it would no longer conduct any voltage at all through the sensor. In the remaining 23 of the cases, what we found when we put the sensors on the test bench was that the measurements of the levels of current that were passing through the sensor when subjected to different amounts of airflow would be out of tolerance or out of range, as we would say. So in other words, when compared to a brand new, perfectly functioning sensor, we could detect that the 23 sensors we're talking about now were not passing or were not fluctuating their signal in a manner similar to a new sensor. Again, to summarize, out of the 23 sensors that we tested as malfunctioning out of a total population of 107, 14 of those sensors were contaminated with silicone. 5 of those sensors had some level of dirt visible on them at high magnification, and 4 of the sensors were perfectly clean. None of the sensors that failed on the test bench or that showed any deviation from the amount of electrical current they should be passing when compared to a new sensor, none of them had any K&N filter oil on them when subjected to a chemical analysis. We've discovered that oil will not come off of a K&N air filter under any normal operating conditions inside of a vehicle.
A significant percentage of the mass air sensors that were sent back to us had a silicone contamination present on them. That didn't necessarily mean that the mass air sensor was defective, because many of those still operated properly even though they had a silicone contamination. Now the silicone comes directly from the mass air sensor itself.
To understand where silicone would come from, we had to go back and understand how mass airflow sensors were actually manufactured, and learn that there's quite a bit of silicone in a mass airflow sensor and an opportunity for it to creep down onto the actual sensor wire.
Due to the mass air sensor living in such a difficult environment with vibration and heat, when they assembled the mass air sensor, the area at the very top of it where the circuitry is filled with a silicone compound to isolate it or insulate it from vibration and heat. It is then sealed up at the end as the final process. The thermistors connect directly to the bottom of the circuit board that is basically sealed in this silicone material. What happens on some of these, as they break down, the silicone will creep underneath the circuit board and work its way down the heated wires that the thermistor is attached to. There are 3 separate factory technical service bulletins that are out there right now that address the issue of mass air sensors being contaminated by crankcase vapors through the PCV system. The evaporative canister system also bleeds into the, feeds into the air intake. All of those gases are percolating around there, especially when the vehicle is shut down and air is no longer moving through there. You have all of those vapors that are mixing around inside the system. That's the other reason that's one of the reasons anyway, that a mass air sensor has a burn-off cycle. Many of them have a burn-off cycle onto it to remove the particulates that may attach themselves to the thermistors or the hot film during that process. Another thing that confirms that gases do exist inside of the air intake is the newer vehicles in the tighter and tighter compliances with EPA are putting a carbon trap, because as the gases move through the intake, they try to escape into the atmosphere. So more and more manufacturers are putting carbon traps in the air box itself to trap the gases there. Well, once they get to the air box, they've already moved past the mass air sensor. It's just the environment that they live in. It's not a clean, pristine environment. Our goal in performing this extensive investigation into the mass air sensors is to determine not who is at fault, but just what happened in the incident. We will use this information to assist the dealer to better understand and also to aid the customer in this warranty issue. It's not really to find fault with anybody, it's just to find out what happened in this particular circumstance. The dealer's customer is our customer is the dealer's customer. It's one and the same person. So we never contact a dealer with an antagonistic approach. It's always a very soft approach that we're just trying to help out and maybe clear up some things. We have tools at hand that a dealership in no way, they do not have at hand. They don't have a microscope to look at these mass air sensors under a 5,000 times magnification. So all the information that we do gather, we urge the dealer to please be receptive to us sending it to them at the end of our analysis. Even if they're maybe a little bit apprehensive, we spend a great amount of time on the phone talking to them to help educate them. It's a valuable tool. It's information that they will probably never see from anybody else. And it's a great educational process.
As I mentioned at the introduction to this video, I went into this investigative process with the assumption that there was a real situation or there were real circumstances in which elements could combine to create a circumstance in which oil could come off a K&N air filter and foul a mass airflow sensor. My goal was specifically to identify what those circumstances were, what those particular vehicles were, or what those particular type of sensors were in which something could happen. As you've seen from the testing we've done, the result has been that in fact it's never happened to the best of our knowledge and belief based upon physical testing and forensic laboratory analysis. On behalf of K&N, I guess I can say that the best thing about this entire process we've been through is the extent to which it's reconnected us with real consumer experiences with our product in the world as they take their cars into dealerships. And it's helped us understand how important it is for a manufacturer to not just stand behind its products, but to stand behind its consumers. And so in addition to the fact that we sell replacement air filters that are backed by the world's first million-mile warranty, we now actually offer something that we call our Consumer Protection Pledge, which means that we pledge that consumers that buy and use K&N products will never be allowed to be in a position where they're in the middle between a service provider or a dealership who believes our product has caused a problem and K&N. We have a dealer relations department now who will step right into that situation, interact directly with the dealership or service provider, and resolve that consumer's problem one way or another. We're very proud of this pledge because we think recognizing our obligation to consumers is even one step ahead of backing our product with a million-mile warranty.